Hello everyone. In this video, we will take a look at linked list cycle problem where we have to detect whether there is a cycle in the linked list or not. So we are given with the head node and we have to determine if the linked list has a cycle in it. Uh, and we return the true if there is cycle in the linked list. Otherwise, we should return false. So for example, in this linked list, 3, 2, 0 and 4, as next node of -4 is 2, there is a cycle because this list does not end with null after -4. So we have to return true in this case. Here also there is a cycle, so we return true. In the third example, there is only one node, and so next of this one is null, and hence there is no cycle here. So we have to return false in this case. So we can solve this problem using Floyd's hare and tortoise algorithm. So what this algorithm says is that as tortoise is slow than hare, so let's suppose that the tortoise moves by one place. At that in that time, hare will move by two places, and if hare reaches till the end first, that means that there is no cycle in this linked list. Otherwise, basically, if hare can catch tortoise again, that means there is a cycle in the linked list, because otherwise hare would reach till the end, and hare and tortoise won't meet again at the same node. So if we take a look at this example again, in this case, when there is a cycle, as we said in the algorithm, when the tortoise moves by one place, hare will move by two places. Again, tortoise moves by one place, hare will move by two places. So hare will come at 2, because after -4, it is again linked, its next node is 2, so hare will come here, and again the tortoise moves by one place. At that time, hare will again move by two places, and hare will meet again tortoise at this node -4. That means that there is a cycle in this linked list. In this case, when there is no cycle, basically when tortoise moves by one place, hare will move by two places and reaches to 0. When tortoise will come at before even coming at 0, basically we can check that the after this uh, after this loop, basically in the next iteration for this for this hare is going to reach at the end of this linked list, because there is null after -4. Hence we can break this loop and come out of this saying that there is no cycle in this linked list. So if we take a look at the source code of this problem, basically we are given with the head of the linked list, and we have to return whether there is a cycle or not. So we return true if there is a cycle, we return false if the cycle is not present. So first condition we need to check is if the head itself is null, that directly means that there is no cycle in this linked list, and hence we return false in this case. Then we initialize two pointers, slow pointer and fast pointer. So slow means our tortoise, and fast means our hare. And we assign both of these pointers to the head. And then, as we said, that when the fast pointer, that means when our hare reaches till the end, when till the time it reaches till the end, we move our slow pointer by one, and we move our fast pointer by two places. And if there is a condition where both of these pointers meet at some place, so for example, in this case, when these when these two pointers meet at one node, that means that there is a cycle. Hence, we break this loop and return true in this case. And if this condition is never met, and in that case, basically the fast pointer will reach till the end, and we will come out of this while loop. In that case, the definitely the cycle is not present, because fast pointer reached till the end, and that means we come out of this while loop and will return false, because the cycle is not present in this case. So that overall time complexity in this case will be O of n, because at max our slow pointer will cover n number of nodes, where n is the number of elements in our linked list.